All right, so in this video, we're going to be writing equations of parallel lines, all right? And one thing we need to remember is that parallel lines must have equal slopes, okay? The slopes must be equal, all right? So in number one, we're given the equation of a line, okay? The equation of the line is y equals x plus 4, all right? We want to write an equation of a line that's parallel to that line and that goes through the point 1, negative 2, okay? So the given line, y equals x plus 4, has a slope that we know to be 1. Okay, remember the slope is the number in front of the x, or the coefficient of x. There's no number there, but we should know by now that it's understood to be 1. So the slope of this line is 1. Okay, because of that, the slope of the parallel line must also be equal to 1. Okay, and it also goes through the point 1, negative 2. And that was given in the question here, or in the problem here. Okay, so what we want to do, okay, is realize that these two slopes match up, okay? If they don't match up, then we don't have parallel lines. And we're going to use that information. We're going to use this slope and this point, okay? And we're going to plug those into point-slope form so we can write an equation of a line. And then we'll convert it to slope-intercept form, okay? Again, we've done all of these things individually. Now we're throwing it all together, okay? So point-slope form, it's going to be y minus the y-coordinate, okay? So y minus negative 2. Equals m, which is our slope, times x minus the x-coordinate, okay? And now I want to clean this up. So on the left side, I've got minus a negative 2. That becomes y plus 2. And I'm going to distribute this 1. 1 times x is x. 1 times negative 1 is negative 1, okay? So when I convert it to slope-intercept form, I'm going to subtract 2 from both sides, okay? And I get y equals x minus 3, okay? So again, I can tell by looking at these two equations that they have to be parallel because the slope is the same, okay? And you can always check your work. If you want to plug in these coordinates, plug 1 in for x, plug negative 2 in for y, this is going to become a true statement. So there's always a way to check your work, okay? So that's the equation of the line parallel to the given line that goes through the point 1, negative 2, all right? Now in number 2, our given line is not in slope-intercept form, okay? So we need to convert it to slope-intercept form by moving the 2x over to the right side, okay? So when I move the 2x over to the right side, I get y equals negative 2x. The 2x moved over here, so we had to change the sign. So negative 2x minus 1. So because of that, the slope of my given line there has to be negative 2, okay? Now, the parallel line has to have the same slope, okay? Notice those match up. They have to match up. And it goes through the point that we're given in the problem here, 3, 1, okay? So just like we did in number 1, we're going to plug these into point-slope form, okay? So y minus the y-coordinate is 1. So y minus 1 equals the slope, negative 2, times x minus the given x-coordinate, so x minus 3, okay? On the left side, there's nothing to simplify. On the right side, I need to do distributive property. So I get y minus 1 equals negative 2x plus 6. I'm going to add 1 to both sides because I want to get into slope-intercept form, okay? And that gives me y equals negative 2x plus 7. So again, you can tell that my given line had a slope of negative 2. My parallel line must also have a slope of negative 2, okay? So that's how you write the equations of parallel lines when you're given a point that the second line goes through.